Hi, my name is Samazuri Fibri, matrix number DE100166. Okay, now I will explain to you about the CNN module. So here, for the first step, which is we need to connect the Google Drive, and after that we need to feed the dataset that directory import the OS, and the step 3 is the create, train and validation data directory. So here, we need to create the file in terms of train and validation in the Google Drive so that we can import it in the Google Colab. So as you can see here, the cane train length is equal to 156, pet train is equal to 310, and also the var length is 156 and var length is 133. So this is all the value of the total image in the Google Drive. So after that we construct the CN model. So here we construct the CN model. So as you can see here, there has convert to D underscore 1, convert to D underscore 2, and we apply the flatten and the dense. So after that, after we apply the CNN module, so we pre-process the input data. In the pre-process input data, we need to classify the name of the object that need to CNN. So for the first one is the cane and the second one is the pet bottle. So here as you can see here, this is the label of the train in the train folder. So the next step is the step number 6, which is we start training the process. So when we use the epoch is equal to 10, so it will pop up the accuracy of the epoch is 10, and also the validation of epoch is also 10. So when we run this step number 6, so we can get this result. For the first graph which is will show the train accuracy, and for second one will show the training loss graph. So it will show the smooth graph, which is the Google Colab can identify, which is the can and which is the pet bottle. So after that, we need to set up the picture where we need to put the three model picture, which is this the first picture, and this is the second picture. Last but not least, this is the third picture. So we go through with the first picture. So as you can see here, when we put this picture, the Google Colab can identify that this is the 100% cane, which is this is the 100% of the pet bottle. Meanwhile, for the picture number 2, when we change the direction of the bottle, so we can see here the Google Colab also can detect which is cane and which is the pet bottle. So here this is a 100% cane and this is a 100% pet, and same goes to the picture number 4. So we change the cane position. So as we can see here, the percent of the cane is the 100, and also the percent of the pet bottle is the 100. So this is for the CNL model in our assignment.
So for the second method that we use in task 2, we use VGG16 model from CNN model. The step is same to create this VGG16. So the first one, we need to connect the Google Colab with Google Drive. Then we create the dataset directory for the data. Then we create the train and validation data directory for our dataset. To construct the pre-trained model with GGG, we use this code. Then we can see it here is the VGG16 architecture. So the input and two block of convolution and one block of max pooling. Then is repeated like this. So we can see this is the VGG16 architecture. Then we generate the data image of the data set. Then we can see here, this is the data for our data set. So for 1.0 is for pet bottle, and 0.0 is for can. Then we can start the training process by using this. We use epoch is equal to 10. Then the accuracy for training is 1, and the validation accuracy is also 1. So for the outcome of this accuracy, the result, we can see here, this is the table for this graph for the training and validation accuracy and training and validation loss for VGG16 by using VGG16. So based on this, the highest accuracy of the VGG training is 1, and the lowest is 0.825. For the validation accuracy, it is higher than 0.825. 0.950 to 1. 1 is the highest accuracy for validation. Then for the VGG loss, the higher value of the training loss is between 0.8, between 0.7 and 0.8, and the lowest is 0.0. For the validation loss, it is 0.0 for the lowest, and 0.1 and 0.1 for the highest loss of VGG validation loss. This is the first picture. The pad and can is beside. So the image is 100% can and 100% pad. So the VG system can detect the water and can perfectly. This is the second picture. Also, we can see this is image 100% and can and 100% pad. And the third picture, the water is in front and the can is behind. And it is also can detect the image, which is 100% can and 100% pad. So that's all for VGG system for task 2.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aiman Alimi bin Rizan, metric number DE190129. So today I would like to present on the inception. So first of all, the step 1 is we need to connect to the Google Drive with this coding, and then for the second step we need to feed the data set into the directory import OS using this command, and then for the third step we need to create the training and validation data directory to configure the locations of the training in the data directory using this command. So from this command we can see we can get that there are amounts of pictures in this directory, which is 156, 310, 156 and 133. Right, then we need to import a few libraries of the Google Colab or Python. And then for the third step, we need to construct the inception model. So this is the coding for the inception model. And then we need to run to get the actual model configuration. So here is the model configuration for the inception. And then for the fifth step, we need to pre-process the input data using this command. Then we found out that there are 466 images belong to 2 classes, and then 289 images belong to 2 classes for the validation. And then we know that there are 2 classes, right? Then we need to set the classes, which is cat and PET, right? And then we need to plot the graph. So here is the classification between the bottle and the between the PET and can. You can see that PET is at 0.1 while the can is 1.0. Then we need to start training process. So we will calculate the process based on the epoch that we set. So for this example, we set the epoch equal to 10, so we will calculate the epoch for 10 times. So for the accuracy, here is we can get the 100% accuracy, and then we need to plot the outcome. So based on this outcome, we can see that there are 6 100% epoch for the accuracy, and then 6 loss for the training and validation loss. Okay, the range is quite good for to identify the images. And then we import the first picture, which is can and PET was put side by side. So we get the 100% for can and 100% for PET. And then for the second image, which is tin at the front, and while the bottle at the PET at the back, so we get also 100% and 100%. And the last one for the third picture, which is bottle at the front and the tin at the back, so we also get the 100% and 100%. I think that's all from me. Thank you.